So let's take a look at another example where we're trying to solve this exponential equation. We haven't really dealt with solving using logarithms yet, so we have to try and figure out how can I solve this by trying to make the bases of these the same. So we have 4 to the x minus 1 power, and we have 32. 32 is not easily expressed as 4 to some power, but we can break this down so that these two pieces can have the same base. So if we think about the prime factorization of this, 4 is 2 to some power, right? 4 is 2 to the second power, and 32 is 2 to some power. It's 2 to the fifth. So we can actually break this down and use that property that says if you have two powers with the same base that are equal to each other, then their exponents must be equal. So we can rewrite this 4 to the x minus 1 as 2 squared to the x minus 1. And then that's equal to 32, which is just 2 to the fifth power. Now, if you recall from the laws of exponents, when you have a power raised to a power, then the exponents get multiplied. So this is 2 to the 2 times x minus 1 equals 2 to the fifth. So this, if we distribute through, gives us 2 to the 2x minus 2 equals 2 to the fifth. And then from here, since these bases are the same, we can just take the exponents and set them equal to each other. So we can just take the exponents of each of these and set them equal to each other. 2x minus 2 equals 5, and solve this equation. So add 2, we have 2x equals 7, divide by 2, and we get that x is 7 halves. So if we plug 7 halves back in, that should give us the solution to this equation, to this exponential equation.